Welcome to this session on model stealing attacks. I'm Harry, and today we'll be discussing how attackers can replicate AI models without access to the original data or training processes. We'll explore what model stealing attacks are, the motivations behind them, the techniques used, and the real-world impact. We'll also look at examples across different industries and cover effective mitigation strategies to protect AI systems from these attacks. So let's dive in. What are model stealing attacks? Model stealing attacks involve extensively querying an AI model to extract its decision-making logic. The goal here is to replicate the model's functionality without needing access to the original data or training. Attackers are going to collect input-output pairs to approximate the model's behavior, recreating it for purposes. These attacks can have severe multiple objectives. Replicating the model for similar uses, stealing proprietary functionality, reducing the time and cost associated with developing a comparable model, or gaining an unfair competitive advantage by leveraging stolen AI capabilities are just some of the few. So now let's dive into the motivations behind model stealing attacks. One major driver is the desire to avoid high costs and time investment required to build similar models from scratch. Attackers can quickly gain access to high-performance models through systematic queries, bypassing months or even years of research. In some cases, the goal is to bypass legal restrictions, such as licensing or data usage limitations. Others might engage in unfair competition, deploying these stolen models to undercut the legitimate providers to gain an edge in the market. There are several techniques that attackers can use to steal models. Input-output pair collection is one of the most common, where attackers query models with numerous inputs and record their outputs. Decision boundary approximation involves mapping how the model classifies or predicts in different scenarios. This would allow attackers to mimic its behavior. Shadow models are another tool. They are basically replicas trained using the data collected from queries from these models. And then attackers may also leverage active learning strategies, carefully selecting the queries from the model that provide the most valuable insights into the model's internal logic. So some more advanced techniques will be varied based on the attacker's access level. Black box attacks involve internal knowledge of the model's architecture, relying only on input-output queries to replicate its behavior. White box attacks, on the other hand, leveraged insider knowledge to optimize the stealing process. Some attackers can exploit API abuse, often overusing the public endpoints to extract data systematically. Transfer learning is another advanced method. Attackers start with a pre-trained model and refine it using the stolen data, reducing the effort needed for replication. So the consequences of these model stealing attacks can be quite severe. Mostly, intellectual property theft will be occurring. This is where proprietary models are going to be replicated, undermining the original developer's competitive advantage. Economic loss will soon follow, as stolen models reduce the returns on investment made during development. Another major issue is going to be trust erosion. When organizations can't safeguard their models, stakeholders are going to lose their confidence in their services. Additionally, market saturation can occur. As stolen models flood the market, it's going to devaluate the original innovations and making it harder for legitimate providers to compete. So now let's look at some of the examples here in model stealing attacks. These aren't just theoretical, they've been observed across multiple industries. In image recognition, attackers can replicate systems by querying them with various images. Language models like chatbots or translation tools can be replicated by submitting different text inputs and recording their outputs. Financial models used for stock trading or risk management assessments are also vulnerable here. as attackers can duplicate these tools to gain unfair market insights. Recommendation systems used by streaming platforms are prime targets as well. Attackers can build similar algorithms by querying them with diverse user profiles. So, how do we stop model stealing attacks? The mitigation strategy behind model stealing attacks requires a multi layered approach. Access controls is crucial. These will limit who can query the model, and it would reduce exposure. Query rate limiting prevents attackers from submitting too many queries in a short amount of time, making it harder for them to collect the data for replication. Monitoring and logging querying patterns is also critical to detect early signs of suspicious behavior. API throttling adds another layer of protection by restricting excessive usage. Output randomization introduces variability in responses to hindering replication efforts, while watermarking embeds unique identifiers in the model to trace unauthorized use in the models. Differential privacy further protects sensitive information by adding noise to queried responses. To sum up, model stealing attacks pose a significant threat to AI systems, leading to the loss of intellectual property, financial damage, and trust erosion. By systematically replicating models through extensive queries, attackers can undermine the investment and innovations of legitimate providers. However, with the effective mitigation strategies like query limiting, monitoring, and advanced techniques such as watermarking and differential privacy, organizations can safeguard their models and ensure models remain secure. Staying vigilant and continuously improving defenses will be essential as our threat landscape for AI systems is going to be continuously evolving.